So here I'll assign the variable x to the weight of this initial alloy, and I'll say that F is the fraction of silver in this alloy. So two variables here. And so if I start with this first piece, this alloy X is mixed with 3 kilograms of pure silver, and the result is that we have 90% silver. So total, that would be equal to 0.9. So, and that's numerator would be the amount of silver, which would be XF, because I'm multiplying the fraction of silver in it, plus 3, because all of it is silver. So that's the first relationship. In the second one, if the same weight of the initial alloy is mixed, so again we're taking X kilograms with 2 kilograms of another alloy, so now we have a total of X plus 2 kilograms, and that has 90% silver. So the amount of silver would be XF plus 2 times 0.9, and the result is that we end up with 84% silver. So this is the fraction of silver, and that's the total amount of silver. So these are my two equations, and we can use that to figure out what X is. So I'll multiply this, XF plus 1.8 is, and I'll distribute that 0.84, X plus 0.84 times 2. Here this becomes XF plus 3 is equal to 0.9x plus 0.9 times 3. So I'll just kind of write these one underneath the other and then do the subtraction here, because that would get rid of the F variable. So I'll end up with 1.2. This becomes 0.06x, and then I'll just have to do this calculation. I don't see a way to I guess you could factor something here. 2.7 times 1.68. So this would be 1.02. And then I will divide this by, actually multiply it by 10. And so that becomes 1.8. Yeah, I think you can just use calculator at this point. And I get 3 kilograms, which is the correct answer.